In this chapter, we will be dealing with defining congruency, then defining congruence of a triangle, the various criteria that will determine the congruence of the triangles, some properties of triangles, and then the most important inequalities of a triangle. So these are the things which we will be discussing in this chapter. Now let us talk about congruent figures. Which figures are congruent? Two figures will be congruent if they superimpose each other completely, or I can say if they fall over one another exactly, you say that the two figures are congruent. Here I am having two triangles ABC and DEF. Are they congruent? In order to check whether they are congruent or not, the most simple and the basic way is try to put on one triangle over the other so that it covers the other triangle completely. Hey, listen. Here, it has completely covered the triangle. The second triangle has completely covered the first triangle. So I can say the triangle ABC and DEF are congruent. Now look at this pair of circles. I got two circles, one with the center G, another with the center G dash. Are they congruent? They will be congruent if the circle G1 exactly falls over the circle G2, the circle with the center G. Let us see. Here, the circle with the center G1 exactly fell over the circle with center G. So these two circles are congruent. Is there any other way by which we can know that other figures are congruent? In case of triangles, we have certain methods by which we will be knowing whether it is congruent or not. Other figures can be tested whether they are congruent just by superimposing over one another. Here I have some more congruent figures. You can see very clearly that the polygon I2, M2, L2, K2, J2 will be congruent to I1, M1, L1, K1, J1 polygon if I can superimpose one polygon exactly over the exactly over the other. So I bring it here and I place it here. You can see they're exactly falling over one another. So the second polygon, or I can say the first polygon, is congruent to the second polygon. Similarly, you're having two squares here. When will these two figures be exactly equal? When we say that when we can superimpose exactly over one another. And if we can superimpose over one another, then they are congruent. So these two figures, that is these two polygons on my left hand side and these two polygons on my right hand side are congruent. A triangle is the smallest possible polygon. In this figure, ABC is a triangle and it is made up of three sides. It has got three angles, and we also say that a triangle has got three vertices. The three sides are AB, BC, and AC. Three angles are angle A, angle B, and angle C. And the vertices are A, B, and C. So once again, a triangle is the smallest possible polygon made up of three sides. Children, now let us talk about congruence of two triangles. Here we are having two triangles PQR and XYZ. The side PQ of triangle PQR and the side XY of triangle XYZ are equal. Similarly, PR is equal to XZ and QR is equal to YZ. If you see the angles here, angle P is equal to angle X, angle R is equal to angle Z, and angle Q is equal to angle Y. Now, since these triangles have equal sides and equal angles, then we can say that the two triangles are congruent. That is, if in two triangles all the three sides and all the three angles are equal, then the two triangles are said to be congruent. I can just show you. If I just take this triangle and put it over this triangle exactly, they fall exactly over one another. I bring it back here. The sides which exactly fall over one another, that is xy is falling on y's PQ, xz is falling on PR, and yz is falling on QR. They are said to be the corresponding parts of these two congruent triangles. Similarly, the angles. Angle X falls on angle P, you can see that. And then angle Y falls on angle Q and angle Z falls on angle R. So these angles are also said to be the corresponding angles of these two congruent triangles which are equal. So these sides and these angles are called as the corresponding parts, that is PQ and XY, QR and YZ, PR and XZ, angle P and angle X, angle Z and angle R, angle Y and angle Q. They are the corresponding parts which fall over one another. You call them as the corresponding parts of the congruent triangles. The vice versa is true as well. That is, if the triangles are congruent, then the two sides, the corresponding sides, if PQR is congruent to XYZ, then PQ will be equal to XY, QR will be equal to YZ, and PR will be equal to XZ. That is, PQ will be equal to XY, QR will be equal to YZ, and PR will be equal to XZ. Similarly, talking about the angles, angle P will be equal to angle X, angle Q will be equal to angle Y, and angle R will be equal to angle Z. So, if the two triangles are congruent, then the sides and the angles will be equal. What did we learn earlier? If in a triangle, if the sides and angles are equal, then the two triangles are congruent. These are the two corollary statements. Okay? Every time you are given two triangles and you are asked to find out whether they are congruent, we have to look for all the sides and all the angles and then verify if they are equal, and then we determine whether the triangles are congruent. Is it not a cumbersome activity, always finding all the three sides, all the three angles, and then comparing? In order to make this easy, certain rules have been formulated, which makes us which help us to identify whether the triangles are congruent. For example, we have the first axiom, which is called as the SAS axiom. What does this SAS axiom say? It says that if two sides of two triangles, if any two sides of two triangles are equal and the angle in between the two sides, that is the included angle, is also equal, then I can say that the two triangles are congruent using SAS, which stands for side angle side rule. In these two triangles, LMN and ABC, or ABC and LMN, I can say AC is equal to LN, BC is equal to MN, and angle N is equal to angle C. So, since these angles are equal and these two sides are equal, then I can say that these two triangles are congruent. This is a rule and it need not be proved. That is, if you know two sides of any two sides of triangle, they are equal, and if the included angle is also equal, then we can easily say that these two triangles are congruent. I can show it. See, they're congruent. I don't know all the sides, but I know two sides and the included angle. I can even show the angle. We can see whether the angles are equal. So you can measure the angle. This is 24. This angle also, let me measure for you. Angle C. Also, if you measure this particular angle, you can see that it also will be, definitely will be 24. See, the angles are equal here. This is 24, this particular angle, and this particular angle is also 20. Okay, so this is the SAS rule. If two angles, if two sides and the included angle of a triangle are equal, then the triangles are congruent using SAS rule. Now let us talk about another rule, which is called the ASA rule. The ASA rule stands for angle, angle, and the included side. So if you're having two triangles ABC and LMN, if angle L is equal to angle A, angle N is equal to angle C, and the included side, that is ln and AC are equal, that is these two angles are equal, these two angles are equal, and the side that is in between, they are equal, then again the triangles will be congruent. You need not know other sides. With these two sides, I can say these three things, that is two angles and the included side, I can say that the triangles are congruent. And this rule is called as the angle side angle, or the ASA rule. Now children, since the sum of three sides, three angles of a triangle is 180. So if two angles are equal, then definitely the third angle will also be equal. That is, angle M will be equal to angle N because of the angle M will be equal to angle B because of the angle sum property. So this ASA rule can be slightly extended to calling it as AAS rule. That means it is not necessary that this particular side which we know, it should be in between the two angles. It can be any one of the sides, because अगर दो angles equal है तो definitely third भी equal होगा. तो कोई ज़रूरी नहीं, it is not necessary that the side which we are talking will always lie in between the two sides. आप अगर ये दो sides के बारे में भी मालूम है और ये दो angles, if I know these two angles are equal, then, and if these two sides are equal, then also I can say the triangles will be congruent, because तब भी आपका ASA rule follow होगा. Okay.